Hello, so today we are talking about binomial random variables, and this is to build on what we talked about in class, so please make sure that you have those previous notes in addition to this video. So this is section 6.3 in your textbook. Please go there for extra examples and some more practice with these concepts. So just to review what we talked about in class, the first thing we talked about was what makes something this thing called binomial. What makes something a binomial random variable? And we gave a little acronym. We said BINS, and BINS stands for it's binary. There's only two outcomes. Each trial is independent. The number of trials is fixed, so it's going to tell me how many trials in the problem. And lastly, the success probability, or P equals, is the same every trial. And that goes along with it being independent. These two are kind of connected. So another thing we talked about was this giant formula. We said how we calculate binomial random variables is by using this massive formula. We broke down the formula and we said that this piece right here, we read this as n choose k. So this piece right here we call n choose k. And what that piece is this formula right here, n factorial over k factorial times n minus k factorial. And we said a factorial, for example, 4 factorial is 4 times 3 times 2 times 1. So factorials are just that number times all the numbers below it. And that's a review from Algebra 2. But we really broke it down and said, what do all these parts mean? This giant formula, what are these four pieces? And we said the first piece is the probability that you have exactly k successes. So the probability that x equals k means the probability the number of successes is a number, and k is going to be a number. This piece right here that we just saw with all the factorials, that tells us the order of successes doesn't matter, meaning I can get a success on the first, second, third trial, or I can get a success on the 4th, 9th, and 11th trial. It's still the same outcome probability-wise. This p to the k piece, we said is the probability of a success raised to the number of successes I want, meaning I'm going to have this many successes, and then I'm going to have a couple failures, so the probability of a failure is 1 minus the probability of a success raised to the number of failures, or the number of trials minus the number of successes. So we broke down this formula into the four pieces, but we also did calculator steps. We said that your calculator is going to have some awesome tricks and tools to help you be successful. And this is 394, the calculator steps. So make sure that you get these calculator steps down. Also note you must write what you're doing. You can't just write this. You have to define your variables, and we worked through that in class. So key point 1, if we use our calculator, we still need to write what probability we're looking for, write out n, p, and x in context of the problem. So today, and kind of this video's purpose, is to talk about the mean and standard deviation of a binomial random variable. So if a random variable x has a binomial distribution with n observations, or a set number of trials, and the probability p of a success, then the mean and standard deviation are as follows. So make sure you get down these formulas. These formulas are super important. So the mean, I can move this little arrow so you can see standard deviation. The mean of a binomial random variable is the number of trials times the probability of a success, or the average or expected value. The standard deviation is the square root of the number of trials times the number of successes, the probability of a success times the probability of a failure. So these formulas can only be used for binomial distributions. It has to pass the Bin's test. Not all discrete random variables. So let's take a look at an example. We're still back at Bob. Bob is still taking this multiple choice test. I know we're probably tired of hearing about Bob. With 6 questions and 5 answer choices, what is the average number of questions he will get correct on the 6-question test? Well, n is 6 questions. The probability of a success is 1/5, or 0.2. So we have a 20% chance of getting it right. And we want to know, what is the mean? Well, the formula that we just saw is that the mean equals n times p. So 6 times 0.2, that gives me 1.2. So if I write that in context of the problem, the average, or the average number of questions Bob gets right is 1.2. So this would be a complete answer. You need to show this work. You need to show your formula, and then you need to write it in context of the problem. This is very picky in the AP world. They want to see this context of the problem written out. So B says, what is the standard deviation of this 6-question test? Well, if we look back, my standard deviation is the square root of n times p times 1 minus p. Well, we already defined n and p up here, so the standard deviation is 6 times 0.2 times 1 minus 0.2. And when I do that in my calculator, I get 0.9797, or we could round that to about 0.98. So that's his average deviation. That's how much he's going to stray from question to question on average. So that's a pretty big spread. It's about a 1-question spread. This is not a percent. This is a standard deviation, or the amount of spread that this distribution has. So this is example 1. Let's take a look at another example. It says a basketball player is traditionally a 72% foul shooter. In a season, he takes 427 foul shots. So part A says, what is the probability he makes less than 300 of the shots? Well, if I think back, this is referring to the formulas that we were talking about earlier. The probability that X, or the number of successes, is less than 300. That's what I'm looking for. Well, in order to use my formula, I need to define a couple things. N is 427 shots, and P equals 0.72 shots made. So I define my variables, and X is the number of successes, or the number of shots made. Well, if I want to use my formula, and if I think about the two formulas, I have a PDF and a CDF. If it says less than, this would be binom CDF. And we said that binom CDF stands for cumulative, so less than, meaning everything below 300, not just exactly 300. Well, in my parentheses, I do N, comma, P, comma, well, the last number has to be the probability x is less than or equal to something. Since the problem said less than 300 and my inequality sign is just less than, in order for it to be less than or equal to, I need to make the number of shots 299. So just to repeat why I did that, 299 would be less than or equal to, and we said this last number that I enter, my binomial CDF is going to go through that number. I don't want to go through 300, I only want to go through 299. So when I do that in my calculator, I get 0.195. I can round 3 decimal places. So there's a 19.5% chance that he makes less than 300 shots. So all of this work is needed for these problems. You need to show what your variables are and define them, show you putting it into the formula, and then interpreting this number in context. So let's take a look at B. It says, what is the probability he makes more than 320 shots? Well, we said in class the probability that x is greater than 320 is the same as 1 minus the probability x is less than or equal to 320. The probability it's more than 320 shots is 1 minus the probability it's less than or equal to 320. Well, I already defined my variables up here, but I can do it again. N equals 427 shots. P is 0.72, or 72% made, or success rate of 72%. So when I go to put this in my formula, 1 minus, it's binomial and it's less than or equal to, so my number stays the same at the end of the problem, binom CDF 427 times, comma 0.72, comma 320. And when I do that, I get 0.07838. So just, we can round it to those 3 decimal places, 0.078 or 7.8% chance he makes more than 320. So make sure you have these 2 examples down. These are really great examples. And let's take one more look at the mean and standard deviation formulas. So it says find the mean of the distribution. Well, we know the mean is n times p. We already defined n to be 427 times p of 0.72. And when I do that, I get the mean to be 307.44. Or he's expected to make about 307 shots. For standard deviation, my formula is the square root of np times 1 minus p. So the standard deviation is the square root of 427 times 0.72 times 1 minus 0.72. And when I do that, I get the standard deviation to be 9.278. So that's another example of standard deviation. So now we have 2 examples of mean and standard deviation and some more examples of stuff from class. Key point number 2, we can use the formulas for mean and standard deviation. Remember, mean and expected value are the same thing. We use those to find the center and spread of binomial random variables. And that's a wrap. Binomial random variables are special type. Special type is key because they have different formulas than regular discrete random variables. We determine if something is binomial if it meets all the requirements of bins. So that's a wrap, and we'll see you next time.